Okay, so this problem says for a standard normal distribution, find the value of C for which probability of Z of C is equal to 0.5573. Okay, now first of all, this here is the probability. And we're trying to find out which value of C will yield this probability. Okay, so anytime you're given a percentage or a probability, we're going to go to the normal distribution, as you can see here, but we're going to click on Find Percentile Quantile. So when do we do this? We do this anytime you're given a probability or a percent. Okay, if you're given a probability or percent, you're going to click on Find Percentile Quantile. So let me show you guys what that looks like. We're going to go to our calculators page, and we're going to click on binomial distribution. And then here, we're going to click on Find Percentile Quantile. Okay, so because we have a z-score, the mean is going to be 0 and the standard deviation is going to be 1. Okay, so once again, for any z-score, the mean is 0, standard deviation is 1. Now, type of percentile, is it lower tail, upper tail, or two-tailed? So because our inequality is less than, it is going to be lower tail. If it was greater than, it would be upper tail. So I'm gonna pick lower tail because the inequality is less than. Now, what is the probability in the lower tail? The probability is 0.5573, but notice that it needs to be in percent. So if I multiply this by 100, I'm going to take 0.5573 times 100. This will give me 55.73. So I put in the probability in the lower tail, and as we can see, in the lower tail, we have a probability of 55.73%, and that value is going to be 0.144. Okay, and you can even see that right there, 0.144. So for Z less than 0.144, the probability is 0.5573 or 55.73%. Therefore, in this case, the value of C is going to be 0.144. Okay, in the country of United States of Heightlandia, the height measures of a 10-year-old are approximately normally distributed with a mean of 55.8 and a standard deviation of 2 inches. So anytime you're given a mean and a standard deviation for a normally distributed data set, we're going to click on the normal distribution. And then we're going to plug in our mean and our standard deviation. So the first one, part A, says, what is the probability that a randomly chosen child has a height of less than 58.2 inches? So given that the mean is 55.8 with a standard deviation of 2, we want to find out what percentage of kids are less than 58.2 inches tall. And for that, we're going to say we want to know the probability that, oops, sorry. Sorry about that. We want to know the probability that x is less than 58.2 given a mean of 55.8 and a standard deviation of 2. So let's go ahead and plug this in. Okay, first thing we have to do is we have to go to the normal distribution, and we're looking for a probability. So anytime you're looking for probability, you're going to click on, of course, Find Probability. All right, so the mean is 0, standard deviation is 1 for z-scores. However, we don't have a z-score. We're given a mean and we're given a standard deviation. So our mean is 55.8 inches and our standard deviation is 2. And we want to know what is the probability of selecting a child that is shorter than 58.2 inches. And we can see our probability is 88.49%, which is 0.8849. Okay, we can see right there. Put in our mean, put in our standard deviation. We want to know probability that x is less than 58.2, and that's going to be 88.49%. To convert that to a decimal, divide that by 100, and we're going to get 0.8849. It says to round to 3 decimal places, so 0.8849, that'll be 0.885. Because for 0.8849, the third decimal place is a 4, but the number after that is a 5 or higher, so that means it's going to get rounded up to 0.885. Part B says, what is the probability that a randomly chosen child has a height of more than 54.1 inches. Okay, more than 54.1. So more than, that's going to be the greater than inequality. We're going to click on greater than 54.1. Notice that we're keeping the mean and standard deviation the same. Change that to 54.1 and we get 80.23%, which is going to be 0.8023. But they want us to round to 3 decimals, so that'll be 0.802. Why is it 0.802? Because for 0.8023, we want to round to the 3rd decimal, but the number after that is a 4 or lower, so that's going to be 0.802. Now, what does this tell us? It means that about 89% of kids are shorter than 58.2 inches. About 80% of kids are taller than 54.1 inches. Okay, so this one says systolic blood pressure of adults in the US is normally distributed. Anytime you see this, we're going to click on the normal distribution calculator with a mean of 120 and a standard deviation of 20. So make sure you put the mean as 120, the standard deviation is 20. Someone qualifies as having stage 2 high blood pressure if their systolic blood pressure is 160 or greater. So part A says, around what percentage, now notice it says percentage in this case. What percentage of adults in the US have a stage 2 blood pressure? Give your answers around to decimal places. So we want to know what is the probability that X is greater than 160. Okay, why is it 160? Because when it's 160 or higher, then they have a stage 2 high blood pressure. So we're going to put in our mean and standard deviation. We're going to go to the binomial calculator. Our mean is 120. Our standard deviation is 20. We want to know what is the probability that X is greater than 160. And we get our percentage to be 2.275%. So about 2% of adults have stage 2 high blood pressure. They want us to round to 2 decimals. And this time we're going to leave it in percent form. So it's going to be 2.275%. The second decimal is a 7. The number after that is a 5 or higher, so that's going to round to 2.28%. Okay, stage 1 high blood pressure is specified as systolic blood pressure between 140 and 160. What percentage of adults in the US qualify for stage 1? Now, anytime it says between, we're going to, so in this, our mean and standard deviation don't change. It's going to be 120 and 20. But for in between, you're going to choose an interval. So now you have a lower and an upper value. Our lower value is 140 and our upper value is 160. So we're going to choose 140 as a lower value, 160 as the upper value. Make sure you choose the interval anytime you have in between. And we get our percentage to be 13.59%. The mean daily production of a herd of cows is assumed to be normally distributed with a mean of 36 liters and a standard deviation of 2.2. So our mean is going to be 36 and our standard deviation is going to be 2.2. What is the probability that the daily production is between 33.9 and 35.4 liters? So when you have the word in between, you're going to choose the interval option in the normal distribution calculator. And we want to know what is the probability that X is in between 33.9 and 35.4. Okay, so let's go to our normal distribution calculator. And we're going to put our mean as 36. Our standard deviation is 2.2. Now, because we have the word between, we're going to choose the interval option, this one right here. The interval gives us a lower and an upper value. Our lower value is 33.9. Our upper value is 35.4, and that's going to be 22.26%. We want this in decimal form, so if you divide that by 100, we're going to get 0.2266.